Okay, so what we're doing is we're going to wrap up chapter 16 by figuring out when a binomial model can change to a normal model. So if you have something that is binomial and you have a large enough sample, you can use a normal model to determine the percent instead of doing binomial, PDF, or CDF. There's one condition that must be met. You must have 10 successes and 10 failures. Okay, so that means n times p has to be greater than or equal to 10, and n times q has to be greater than or equal to 10. So you have to have 10 that work and 10 that don't work. If you do that, then what you'll use is you'll draw your normal model, right? You'll use normal CDF, and this is all stuff that we learned way back in chapter 5. Okay, so you'll go second vars, normal CDF, and then you'll have to remember this is where we draw the line in shade. Okay, your formulas for mean and standard deviation are exactly the same as binomial. So the mean is NP, and the standard deviation is the square root. Hold on. Is the square root of NPQ. Okay, so when you have 10 successes or failures, you show that, and then you can use normal model. So let's go ahead and do an example. So historically, 35% of students go to homecoming games. A recent survey of 80 JDHS students was taken at lunch. Show why a normal model is appropriate. So my P is 0.35. P's and Q's is the success and failure, so they add up to 180. Or not 180, they add up to 100. And so Q is 65. So it'll be 80 times 0.35, and that is 28. And that's greater than to equal to 10, so that's good. And then 80 times 0.65, that's 52, which is also greater than or equal to 10, so that's good. So because both of those conditions are met, now we can do the normal model. Okay, so for mean, so the mean, well, there it is. The mean is going to be NP, so it is 80 times 0.35. And you had actually already found it because the mean's right here. And I didn't mention this, but you do have to show this. Okay, you do have to show how many successes, how many failures. And then the standard deviation is going to be the square root of 0.80, why am I doing 0.80? Hold on. It's 0.35, 0.65, and 80. There we go. And the order doesn't matter as long as you're multiplying the P, the Q, and the N. And so this is 4.3. Okay. And so now we get to the problems where you use this. Okay, so I just draw my normal model. I found that my mean was 28. So we're using 28 with 4.3. And then my number, it says only 20. So 20 is on the left of 28. And whenever it's on the left, you're going to shade to the left. And so my fancy calculator app that I usually have on my computer is not working. So you guys will have to kind of listen and hopefully get it okay. So you'll hit second vars, and then you're going to choose normal CDF. And then remember when you do this, it's going to ask upper, lower. My lower is a really small negative number. My upper is the upper side of the shading, so that's 20. My mean is 28, and my sigma, which is standard deviation, is 4.3. And so my answer is 0.031. And so based on historical data, if only 20% of the survey, or 20 people in the survey say they're going to go to homecoming, this would actually only happen 3% of the time. Okay. If you did binomial CDF, it's actually pretty close to this, But when we have 10 successes or 10 failures, you have to know to use the normal model.